Whew, a 12 marker or normal distribution that is actually quite easy. Bet you didn't expect me to say that. So for the first part, it mentions the proportions of metal rods that are less than 7.902 centimeters and asks you to find the standard deviation. Whenever you need to find the standard deviation, usually the question is trying to reference using the standardized distribution, also called the Z distribution. This is one where the mean is 0 and the standard deviation is 1. The reason for it is because you can equate values from your distribution to those from the Z distribution by the equation x minus mean divided by standard deviation is equal to value from the Z distribution. So use your calculator to figure out what the value at which you have an area of 0.025 with the inverse normal distribution from your calculator, and rearrange from their standard deviation. Next one is pretty free answer. Use your new normal distribution to figure out the probability of the rod being between 7.94 and 8.09. Using normal CD in your calculator, and you get 0.849. This one is not really hard if you just pay attention, part C. It gives you info on which rods will be sold for how much, so your job is just to find the probability of that rod being picked, multiplied by the sample size being 500, and then multiplied by the specific cost. So for the small rods, it's 0.115 of the 500 rods multiplied by the cost. The regular size rods are the same as in part B, and then multiplied by 0.5. And greater than 8.09 is 0.03593 of the 500 rods. Tallying up the cost gives you 222 pounds rounded to the nearest pound. Not bad for 5 marks. Finally, in this next question, it really is switching the question to a binomial problem. The reason you can interpret that is because it gives you the probability of failure and therefore one of success. That's one of the key traits of binomial. A sample and how many are faulty. If you have done enough binomial distribution questions, you can see it. He aims to have 95% of the batches being accepted. So by that logic, the probability of x being less than or equal to 5 should be greater than 95%. Because what you're saying is more than 95% of scenarios you should have 5 or less hinges be faulty. Well, when calculating the probability using this distribution, you get 0.9176, corresponding to 91.76% of the time there will be 5 or less hinges faulty. This is less than 95%, so he will not achieve his aim by that logic. The last one, you just need to get a good understanding of what you need to do. But overall, not bad.